Hey there, how's it going, everybody? So in the Matplotlib series that I recently released, I mentioned several times in that series that I had taken that data from the 2019 Stack Overflow Developer Survey. So in this video, I want to show you how you'd go about downloading that raw data from the survey, how we can explore that data to see what's actually in there, and how we can write our own scripts to make some calculations and perform some analysis on that data so that you can pull out that information that you're looking for. So this is going to be great practice for anyone who's wanting to learn more about data science. So this is likely something very common that you'll be doing, downloading data, seeing how the data is organized, and analyzing that data with Python. Now, I would like to mention that we do have a sponsor for this video, and that is Brilliant.org. So I'd really like to thank Brilliant for sponsoring this video, and it would be great if you all could go and check them out using the link in the description section below and support the sponsors. And I'll talk more about their services in just a bit. So with that said, let's go ahead and get started. So when the Stack Overflow Developer Survey results were first released, I saw them posted to Reddit on the programming subreddit. And I was reading the comments, and this one popped out to me. It had 159 upvotes here. So we can see that this guy seems frustrated and commented, "Another effing survey that fails to report language popularity by developer type. Many of those languages are never or almost never used in the embedded world." So I don't want to give this person or the people who upvoted that comment too much pushback, but there are tons of specific questions that could be asked about that data. So it's a bit hard for Stack Overflow to anticipate everything that people want to know about the data. But luckily the data is available for free and we can do that analysis ourselves. So if the person who made that frustrated comment happens to be watching this video, then you're in luck, because at some point I'll also do the analysis that you were looking for, where we break down the popular languages by developer type. So let's get started and see how to do this. So I'm going to open up Google here. And first of all, let's Google Stack Overflow Developer Survey Results. And the first link here should take us to the latest survey. Now, this page actually takes you to the page where they performed some of their own analysis on the data. So you can look through and see what they've already analyzed. So if we scroll through here, then we can see that they break down some of the survey data by geography, some developer types that answered the survey, and things like that. But what we want is the actual data so that we can do some analysis ourselves. So if we scroll back up to the top here, and we read this first couple of paragraphs here, down here at the bottom, right here close to the bottom of these first paragraphs, it says, "Do you want to dive into the results yourself? The results of the survey are available for download here." Now on this page here, you can download the data in CSV form for any year that they have available. They organize these CSVs really well now, but if you try to download the 2011 data, then it's pretty disorganized how they organized it back then. So there might be some data cleanup depending on what year you're downloading. But I'm going to go ahead and download the 2019 data, which is right here. So I'm going to download the CSV file. And once that is downloaded, whoops, let's try to redo that. It looks like that download didn't work. Okay, and it looks like the download worked that time. So now I'm going to open up my downloads folder here. And now I'm just going to unzip the zip file that we downloaded. So I am extracting those. Okay, so once that's downloaded and unzipped, I'm going to go ahead and drag that folder to a folder on my desktop, and that's where I'll write a script to analyze the data. So I have a folder here on my desktop called Stack Overflow Demo. So I'm going to drag this over here, and we can see that this says Developer Survey 2019. That's a little long, so I'm just going to rename that to Data. Okay, so what files are in the directory that we just unzipped? So let me close that down and make this a little larger here. And let's look at the files that are here within this directory. Okay, so first of all, if you download data that comes with a README file, then that's usually really helpful. So if we open this up, then this will tell us all about the data. So let me open up my Sublime Text here. Okay, and I currently have my word wrap turned off, so let me turn that on so this is a little easier to read. Okay, so this README file will tell us about the data here. So we can see here that we have these three files here. We have survey results public, survey results schema.csv, and then we have this SO survey 2019 PDF file. So the survey results public, we can see that it says a CVS file with the main survey results, one respondent per row and one column per answer. The survey results schema is the CSV file with the survey schema, i.e., the questions that correspond to each column name. And lastly, we have the SO Survey 2019.pdf file, and that's a PDF of the actual survey if you want to see how an exact question looked on the survey itself. Okay, so now we know that the survey results public.csv contains the survey results, and the survey results schema has the questions that correspond to each column name in the survey results. So let me open up both of these to show you what this means. So I'm going to use LibreOffice so that it's a bit easier to see everything, but you can use any program that you'd like. Okay, so I will open this one here using LibreOffice, and these are the survey results public, and I will also open the survey results schema as well. And this might take a second to open up since there are so many survey results. Okay, so I have the survey results public.csv file open here, and let me make this text a little larger here just in case it is difficult for anyone to see. So I will just bump that up to 12, and I think that that should be good. Okay, so like we saw in the README file, this file contains the main survey results with one respondent per row and one column per answer. So if we look at the first row here, we have a respondent number 1. And let me make this a little larger here so that we can see this complete column name here. So we can see that we have a respondent, and then we have respondent 1 as the first row. And this row is that respondent's answers to the survey. So let's look through here and find a question and an answer. So we can see here that one of the first columns is hobbyist. So we have this hobbyist column, and their answer to hobbyist was yes. So we can probably understand pretty easily what hobbyist means, but for some of these columns, they're a bit more vague. So to understand what all of these columns mean, we need to look at our other CSV file that is the schema. So let me switch over to the schema CSV file. And again, I will make this text a little larger so everyone can see. And again, in the README file, we saw that this schema gives us the questions that correspond to the column names. So if we find hobbyist down here, it's on row 4, we can see that for hobbyist, that the question that the respondent actually answered was, do you code as a hobby? Okay, so now that we know how to find all of the questions and answers, now we can use Python to analyze this data in just about any way that we'd like. All we need to do is think of a question that we'd like answered, and then find out a way to parse that information out of the data that we have here. So let's start off simple at first, and then we'll look at some more complicated examples. So to start off, let's just see what percentage of people who answered this developer survey said that they actually code as a hobby. So first off, we'll need to create a new Python script, and I'll just do that here within my editor. So I'm going to open up Sublime Text here, and here in my editor, I already have my folder open on my desktop that I called Stack Overflow Demo, and I already have the data here that we downloaded. So we can see here that we have the README, the PDF file, and those CSV files within this data directory. So now I'm going to create a Python script here, and I'm just going to call this Stack Overflow demo.py. Okay, so first, since we're working with CSV files, let's import the CSV module so that we can load in our survey results. Now, if you're familiar with Pandas, then we could use Pandas to analyze this data also, but I'm not going to do that in this video because Pandas is a big subject to itself, so I don't want to do anything using that library that might be confusing to anyone watching who doesn't know how to use that library yet. I'm actually working on a Pandas series right now, so for those of you who are interested, I can do some analysis on this same data using Pandas in a future video. But for now, we'll just use the built-in CSV module to load in this data. Now, if you're also unfamiliar with the built-in CSV module, then I do have a video on that already, and I'll be sure to leave a link to that video in the description section below if anyone would like to brush up on that. Okay, so let's go ahead and import that CSV module so we can load this data into Python. So I'm going to say import CSV, And let me actually maximize this so that we can take up the entire screen here. Okay, so now let's load in our data. So to do this, we can just say with open. And remember, I put that inside of a directory called data. So within data, we want to open the survey underscore results underscore public.csv. And we will open that just as F. And now I'm going to use a CSV dict reader to load in that file. So I'm going to say CSV reader is equal to CSV.dict reader, and we will load in that file. So the dict reader from the CSV module will load in our data as a list of ordered dictionaries. So to see what this looks like, let's just print out the first item of that list of objects, which will be the first response in that survey. Now, this isn't actually a list. This behaves like a generator, so we can't access the items using indexing. It might be easier to work with this data just by casting this to a list, but depending on the size of your data, that might not always be an option. So I'll leave this as a generator for now. So we'll have to iterate over the items, and to do this, we can just say for line in CSV reader, and now we will print out those lines. And to be sure we only grab that first item, I'm going to put in a break here so that the loop doesn't continue. Okay, so now if we run this, then we can see that we got one response here. And this response is an ordered dictionary of the responses that were given for our first respondent of the survey. And if we want to look at their answers for a certain question, then we can access the column name for that question as a key to the dictionary. So if we remember, the column for the question, do you code as a hobby, was called hobbyist. So let's access their answer to that question just by accessing that as a key. So for our line, we want to access that hobbyist column. So if I run that, then now we can see that we just get the response of yes. And if we remove this break statement, then it won't stop the loop after that first iteration, and we'll loop through all of the responses to that answer in the survey. So if I remove that break, and now I run this code, then we can see that it's looping through and printing out everyone's responses from that survey. So there are a lot of responses here, so it might take a second to print all of those out. Now, I should mention that a lot of people like to use Jupyter notebooks to analyze data like this, and there's a good reason for that. Jupyter allows you to run single cells at a time, so you can load in your data and run your analysis on the data without loading in the data every single time. So I have a video on Jupyter notebooks if anyone is interested, but we'll be using a regular editor in this video where it just runs the whole script every time. Okay, so I said we'd start off pretty simple here and just analyze what percentage of people who answered the survey said that they code as a hobby and how many of them didn't. So to do this, let's just track all of the yes and no responses from the survey, and then we can calculate the percentages from there. Now, there are several ways we can do this, so let's walk through a few different ways that we can solve this answer. Now, this is where I see a lot of people beat themselves up when it comes to programming. So they might not be able to think of a solution to this question right away, or if they do think of a solution, then they might do something in a different way than I do it in these videos. And if they do it in a different way, sometimes they think that their way is wrong, but that's not necessarily the case. So let me quickly show you 4 different ways to solve this problem. And if none of these jumped out to you immediately, then that's fine too. The longer that you're programming, the easier that these solutions will kind of pop out in your head. Okay, so I think that some people might be thinking about just having a variable for yes results and a variable for no results and increment those each time we see one of those responses. So that would be one way to do it. So let's do that first, and then we'll look at some ways that we might be able to improve this. So we can say, right above here, I'll say yes count is equal to 0 and no count is equal to 0. And now, in order to keep count of these, we can just have a conditional in our for loop that increments these by 1 each time we see a yes or a no. So in here, I'm going to overwrite this print line, and I'm just going to say if line, and we're going to access that hobbyist column. If that answer is equal to yes, then we will increment our yes count by 1. else, or actually if line is equal to no, then we will increment that no count by 1. Okay, so now let's print out those counts, and make sure that you print these outside of your loop, because if you are inside the loop when you print this, then it's going to print something out every time it increments. So I will now print out our yes count, and also let's print our no count. So if I run this, then again, it's going to take a second just to load in this data, and we can see that we had 71,000 roughly people who said that they do code as a hobby, and around 17 to 18,000 who said that they didn't. So now let's calculate out these percentages. So to calculate a percentage, all we need to do is divide each of these by the total number of answers. So first, let's create a variable above for the total number of answers. So right above our print statements here, I'm going to say that our total is equal to, and that's just going to be equal to our yes counts added to our no counts. And now we can print out these percentages just by saying, I'm just going to modify these existing print statements here. And I'm going to say the yes count divided by the total and the no count divided by the total. So now if I run this, now we get these as percentages. So we can see that about 80% of people who answered the survey said that they code as a hobby, and about 20% said that they didn't. And if you were making a report or something on this data and wanted to clean this up a bit, then we could multiply these numbers by 100 so that we actually have a whole number as percentages. And we could also round these to the nearest 2 decimal places. So let me do that really quick. So I am going to actually create a variable here below total, and I will just call this yes percent, and I'll set that equal to, and let me just grab this here, I'll set that equal to the yes count divided by the total. We'll multiply that by 100. I will do the same for the no count, so let me grab that. Sorry there, made a couple of typos. Okay, so no percentage is equal to no count divided by total times 100. So those will give us whole numbers here. So instead of, 0.08 or 0.801, it'll give us 80.1 instead. So now let's actually round those numbers as well, since we don't really need this to be as accurate all the way out to these decimal places. So I'm just going to do a new line here, and I will say that our yes percent is equal to, and now we will round our previous yes percent, and let's round that just to 2 decimal places. And let me also do this for the no percentage as well. So I'll say no percentage is equal to the rounded version of the no count divided by 2. Whoops, and I didn't mean for that to be no count, sorry. I need to round that percentage to 2 decimal places. Okay, and now let's print these out, and I'll print F strings in order to add some information to what we're printing as well. So within here, I'm going to create an F string, and I will say that the yes answers, then I'll fill in a variable here and say that I want this to be the yes percentage, and then I'm going to put in a percent sign after that as well. So let me copy that and do the same thing for no. So I'll say that the no responses had a no percentage, and then we will have the percent sign there. So now, if I run this, then we can see that this is a bit more cleaned up here. So we can see that the yes responses are 80.17 and the no responses are 19.83. Okay, so now we can see that we get some good information printed out here on how many people code as a hobby. Okay, so this is one way to solve this problem. And I said that I would show a couple of other ways that might improve on this. Now, one way I could think that we could improve this is to use dictionaries to track the number of yes and no responses instead of the integer variables that we have already. So let me show you what this would look like. So let's scroll up here to where we initialized the yes count and the no count. And instead of doing it this way, let's actually use a dictionary for these instead. So instead, I'm going to have a dictionary called counts. And in my dictionary, I'm going to have a key for the yes results, and I'm also going to have a key for the no results. and I'm just going to initialize both of those with a value of 0. So now we have a dictionary called counts, where the keys of yes and no are keeping track of the yes and no responses. Now, the good thing about using this approach is that we don't need to use this conditional inside of our loop anymore, checking if the response is yes or no. Instead, I can just replace this entire conditional. So I will get rid of the entire conditional, and I'm just going to say counts, and then add in a key of our answer for the hobbyist question, and I will just increment that key by 1. So let me explain this one more time here. So since we have a dictionary here, this line of hobbyists, this is going to either be yes or no. So if it's a yes, then it's going to access this yes key here in our counts and increment that by 1. If it's no, then it's going to increment that key by 1. And since we got rid of the yes count and the no count variables, we need to replace where we had those. So down here where we have yes count and no count, I'm going to replace all of those. And we just have 2 of them here. So I'm going to replace those with our counts dictionary and the value of the key yes. I'm going to do the same thing with no count here. We have 2 of those here. So again, I'm going to say counts and access the key of no. So I think that is all the changes that we need to make. If I run this, then we can see that we still get the same results, but this cleaned up our code a good bit since we got rid of those conditionals. Now, one more little tip here. If you ever find yourself initializing a dictionary with certain values like we did here, where we have yes initialized to 0 and no initialized to 0, then it might be a good idea to use a default dictionary from the collections module instead. So default dictionaries allow us to create a dictionary where we don't need to initialize values like this. So let me import this, and then we'll see how this works. So I'll say from collections, import, and that is default dict. And now, instead of initializing our values like we did right here, instead, I'm just going to make this a default dictionary, and I want to say that I want this to be a default dictionary of integers. And now our dictionary knows to expect integers as values to our keys, and it will start at 0 by default. So now we should be able to run this just like we did before. And we can see that now we get those same results, but with our code cleaned up a little bit more. Now, let me show you one last way that we could have done this. Now, the reason that I'm showing you multiple ways to solve one simple example is just because these are some of the same types of problems that you'll likely run into when analyzing data, and it's nice to know what's available to you. So there are many, many times when we run into problems where we're simply counting certain values, and it's so common that there's actually a data type specifically for counting in Python, and it's called counter. And it's from the collections module as well. So let me import this and we will see how this works. So after our default dictionary, I'm also going to import counter. Okay, so now instead of setting this as a default dictionary here at the top of the file, let's instead create a new counter. And just with that small little change, if we run this, then it should look almost the same as what it was when we used our default dictionary. So we can see that we got the same result here, but the nice thing about using a counter is that we get some nice extra features, such as being able to view the most common values with a single method and doing a few other operations that we wouldn't be able to with a default dictionary as easily. Okay, so now that we've seen this easier example of just figuring out what percentage of people answered yes or no as to whether or not they code as a hobby, now let's take a look at a more complicated example and find out the most popular programming languages among the developers who answered this survey. So to do this, we'll need to open up our schema CSV file again and see what column matches with the programming question. So I'm going to open up the schema.csv file here. And these are actually the results CSV. Okay, here's the schema here. Now there are a lot of different questions here on this survey, but just for the sake of keeping the video as short as I can, I memorized where this question is that I'm looking for, and it's down here on row 45. So let me find that. And if you were to read this column in question, then the column is called language worked with. And the question on the survey was, which of the following programming, scripting, and markup languages have you done extensive development work in over the past year? And which do you want to work in over the next year? If you both worked in the language and want to continue to do so, then please check both boxes in that row. So this was actually a two-part question on the survey where they chose the languages they're currently working with and also the languages that they want to work with next year. And again, if you'd like to see exactly how this question looked on the survey, then you can open up that PDF file that was in our download and look at that directly. So this language worked with column is going to be their answer to the languages that they are currently using at this time. So let's go back to our script and see how we can analyze these most popular languages. Okay, so first of all, I'm just going to go ahead and comment out everything here below our for loop. And I'm going to, we might use some of this in a bit, but we just don't need it for now. Okay, and I'm also going to rename our counter here. I'm going to rename this to language counter since we are calculating the most popular programming languages. And now I will instead say language counter, and we don't want to use this hobbyist key here. Instead, we want to use this, let me see, that was language worked with. And again, if you ever forget one of these, then you can just look in those CSV files. Now, before I actually print this out, I'm going to comment out that for now, and let's instead just print the first result of the survey just to see what one of these responses might look like. So again, I'm going to print out the answer for language worked with, and then I'm going to put in a break statement so that we only get the first result of the survey. Okay, so if I run this, then we can see that we get the languages that this specific person said that they work with. So this person uses HTML, CSS, Java, JavaScript, and Python. And we can see that these are separated by semicolons. So this isn't going to be as easy as simply incrementing our counter with the value from this languages worked with field, because we need to split those into individual languages first. So to do this, we can use the Python split method and split these on semicolons. So instead of, above our line here, above our print, I'm going to say that our languages are equal to, and we want to take their answer to this language worked with question, and we want to split that, and let's split that on semicolons. And now let's print out those languages. So if I save that and run it, now we can see that we have a list of those answers instead of the string separated by semicolons. Okay, so now to find the most popular languages, we can loop over this list of languages and increment every one of those with our counter. So now above our print statement here, I'm going to say for language in languages. And now we will increment our languages here. Oops, I actually want to grab this line here. We will increment our language counter with that language, and we'll just plus equals 1 on that. And I'm actually not going to be using this outside of the loop here anymore, since that would give us a false answer there. So I'm going to get rid of that. And now let's print out that language counter and make sure that it looks right just for this one person. So I'm going to print out language counter, and let's run this. And we can see that we have a counter object here, and we have one result for HTML, CSS, one result for Java, one for JavaScript, one for Python. That's good. Now, another nice thing about counter objects is that you can pass them a list of items and just have it increment the counter for each one of those items. And we can do that with the update method. So what we're doing here with this for loop right here, where we are incrementing all of these values by 1, we can do the same thing as this simply by saying language counter.update and just pass in that list of languages to that update method. So now if I run that, then we can see that we got the same results using that update method. So now let's remove this break statement here and see what we get for everyone in the survey. And I'll actually remove the print statement as well there. And outside of this loop, I'm going to print the language counter. And again, make sure that you are outside of your loop or you'll get something printed for every person in the survey. So outside of the loop here, I'm just going to print out our language counter. I will save that and run it. Make this a little larger here. Okay, so now we can see that we get our counts for how many people said they know each language. And the cool thing with the counter is that we can use the most common method in order to see the most popular languages. So if I wanted to just see the 5 most popular languages, then I could, down here at my print statement, instead of printing that entire counter, I could say print dot most underscore common. And let's pass in a value of 5 to that method to say that we want the 5 most common languages. So now if I run this, now we can see those top 5 programming languages. Okay, so we can see how many people said they know each language. And when we used the most common method there, it returned a list of tuples. And each tuple had the name of the language and the number of the people who knew that language. And that'll be good to know in just a second because we're going to loop over these as well. But before we do that, just like we did before, it would probably be better to have these in percentages instead of raw numbers. So we can do this similar to how we did it before. But first, we're going to need to get the total of all the responses so that we can use that value to divide those numbers by. Before, when we only had yes and no answers, we just added them together to get the total. And we were able to do that because the respondents could only respond with a yes or a no. But here, they can choose as many languages as they want. So if we totaled all of those languages up, then we would get a lot more than our total number of respondents because each respondent can have more than one language. So instead, we're going to need to keep a running total up in our loop where we are looping over the lines from our survey. Now, if we had converted this CSV reader to a list, then we could simply take the length of that list as our total. But since this is a generator, I think it'll be easier just to keep a running total. So above our CSV reader line here, or actually it's right below it, it doesn't matter. I'm just going to say total is equal to 0. And below our for loop here, at the end, I'm just going to say total plus equals 1. And now down here at the bottom, let me uncomment out what we had here before. And actually, I can just get rid of that altogether because we've already calculated the total in our for loop. Okay, so now let's loop over those most popular languages and we'll calculate the percentages for each one of these. So we can say, I'm going to copy out these 5 most common languages here. So we can say for language and, that's just language, and value in our language counter dot most common and 5. Now remember that returned a tuple where the first value was a language, the second value was the number of people who said that they knew that language. So within this loop, I can take the same logic that we did before to calculate percentages, and I can just say, let me uncomment out these here, and instead of yes percentage, I'm going to call this language percentage, and the value that we are dividing by our total here, it is no longer our yes values. Instead, it is going to be this value here that was in our language counter most common tuple. And lastly, let's go ahead and print this out. So again, I'm going to take some of the same logic and copy this down here that we used before, and I will print this out. And instead, for our value here, I'm just going to print out the language and then print out the language percentage. Okay, so now if I run this, whoops, and it looks like I got an error here. Some of you probably noticed that as I was typing it out. We are no longer using this yes percentage value here. I forgot to replace that we wanted to round our language percentage to 2 decimal places and not that yes percentage. So now if we run this, then now we can see the percentages of people who said that they use these languages. Now, if you actually go to the Stack Overflow survey results, where they ran some of their own analysis on the data, then their results are very similar to this, but some of these are different by 0.1% or so. And I'm assuming that they used some different criteria for sanitizing their data and filtering out some bad answers. But our results here are very similar to the official results on the Stack Overflow results as well. So for example, some people didn't put any languages down here, which would have been an NA result. So Stack Overflow likely got rid of those. And there's probably a couple of other forms of criteria that they put in there as well. But these are very similar to the results that they got for their survey results as well. Okay, so lastly, now that we have the most popular languages, programming languages for all the people who responded to this survey, now let's answer that question that we saw at the very beginning of the video and break down the most popular languages by developer type. So let's think about how we want to do this. So right now, we're already getting the most popular languages for all of the people who responded to the survey. So the code is likely going to be similar. But now we want to break up the most popular languages based on the type of developer they are. So what I think that we should do here is to have a dictionary where each key is the developer type. And the value for each key in that dictionary will be another dictionary. So these will be nested dictionaries. So I'm thinking that the dictionaries for each developer type will have two key value pairs. They'll have a key for the total number of people in the survey who said that they work as that type of developer, and also they'll have a language counter. They'll have a language counter key that has a value that is a counter object with the language breakdown for that developer type, which is similar to what we already have here. Now, I know that that might sound a little complicated just by hearing it, but it should make more sense once we actually see this. And again, if you're solving this differently than I am, then that's fine. This is just one way that I thought of where we could solve this problem. There might even be some faster, more efficient ways of solving this in a more functional way with comprehensions. But this is how I'm going to solve this in this video. So when you're trying to solve a problem like this, I think it's extremely beneficial to break it down into small steps. So right now, I know that I want a dictionary with all of the developer types as keys. So let's start off with that. So up here above my language counter, I am going to create a variable called dev_type_info, and I'm going to set this equal to an empty dictionary. And right now, I'm just going to remove this language counter here since we're no longer using that specific one. And I'm also going to remove the total here since we are no longer using that specific total. And now within our for loop here, I'm going to comment out everything that we have in here so far. As a matter of fact, I'm going to go ahead and comment out everything below this loop so that we can just work on this small part of this solution for now. Okay, so let me get back up here to being underneath this loop here. Okay, so now let's just break this down one step at a time. So right now, we just want a dictionary of all of the developer types. Now, like we saw before, we can look at the schema.csv file that we've seen before in this video to get the column name for this information. But I went ahead and wrote this down earlier to save us some time. So the column name that we want is called devtype. And just like our programming languages, this is a list of values separated by semicolons. So people can also select multiple developer types that match their line of work. So right now, let's just split those developer types on a semicolon, just like we did the programming languages, and go ahead and loop over those. So I'll go ahead and copy when we did this for languages, and I'm just going to say dev_types is equal to, and this is called devtype. So we want to split those dev types on a semicolon, and now I will say for devtype in devtypes. Let's go ahead and create or say devtype info. And remember, we wanted this to be a dictionary with all the developer types. So we will set that key just equal to an empty dictionary for now. And now I'm going to print those keys from that devtype info dictionary to see if it looks like we got all of those developer types. And remember, print this outside of the loop so that it doesn't trigger that print statement multiple times. So outside of the loop here, I will say print, and we want to, or actually what we want to do is loop over those keys. So I'll say for key in dev type info, and we will print out each of those keys. So now if I run this, then our response should be all of the different development types that people filled in on the survey. So if I scroll up here, we can see, okay, there's that NA value, which means that somebody didn't answer. But we can see that we have desktop developers, front-end developers, designers, back-end, full stack, academic researchers, all kinds of different types here. We can even see that we have the embedded applications or devices that the person was specifically asking about on that Reddit post. Okay, so right now we have a dictionary, and all of these developer types here are the keys for that dictionary. Now we want the values of those dictionaries, or we want the values of these developer types to be dictionaries themselves. And these nested dictionaries will have a key for the total number of people who said that they were this type of developer. And they will also have a language counter of the count of the languages for that developer type. Now, first, we have to think about the loop where we are setting the values of the dev type keys. If that key doesn't exist, then we just want to create a new dictionary with the keys of total set to 0 and language counter sent to a new empty counter. If the key does exist, then we just want to grab the current total and the language counter and update those accordingly. So one way that we can do this in Python is by using the set default method. So let me put this in and I'll explain a bit what it's doing. So instead of setting the key like this here, I'm instead going to say devtypeinfo dot set default. And now we want to set the default for our dev type key. And if this doesn't have a value yet, then now we are putting in our default value. So our default value is just going to be a total set to 0 and a language counter, which is just an empty counter. So let me go over this again just to make sure that this is clear. So what set default does here is that it checks if we already have a value for the key of dev type. And if we do, then it just returns those values and leaves them unmodified. And if it doesn't have a value for that key yet, then it creates a new dictionary with and this is the new dictionary here, with the keys of total set to 0 and the language counter set to a new counter instance. So now we can just update those values like we did before in our commented out section of code, and we'll use these keys instead. So let me scroll down to our commented out code here, and this is where we were updating the different languages in the loop before. So let me actually cut these out and paste them up here. So now for each developer type in those dev types, we still want to grab all of the languages that they work with, and we still want to split those on a semicolon. But now the language counter here that we are updating is no longer going to be the global language counter that we created out here. Instead, we want it to be the language counter for this developer type. So we want this to be dev type info, and then access the dev type key here. And then we want this to be that language counter key. So now we are updating those languages for that language counter for that specific developer type. And now the same thing for the total. Instead of this being a global total here, instead this is going to be dev type info, dev type, and it's going to be that total key for that developer type. Okay, so that should give us the values that we're looking for. So now let's loop over all of those developer types and print out the top 5 languages and percentages using a similar approach to what we did before with our commented out code here at the bottom. So now I'm still going to loop over our dev type info dictionary here, but instead let me make this more clear. Instead of using from key, I'm going to say, or for key, I'm going to say for dev type. And also let's access the values of the keys as well. And so I'll call that info. And now when we're accessing the key and the value, we need to say dev type info dot items. Don't forget the dot items there, because if you just loop over dev type info, it'll only loop over the keys. To get both the key and the value, you want to do dev info dot items there. Okay, so first, let's print out the developer type just to see what developer type these are languages for. And now let me uncomment out everything else that we have here. And I can get rid of these yes and no percentages here. That's from a while ago. All we need now is our language counter. So now when we're looping over this language counter here, we want this to be the language counter for this specific developer type. So that is going to be, remember this info here is going to be the dictionary for that developer type. So we want info, we want to access that language counter key of that developer type. And just one more change here, instead of total, we want this to actually be the total for that developer type as well. So we will access the total key for that developer type as well. And lastly, I'm going to add a tab to our inner loop here where we are printing this out. That way it visually separates this information for each developer type. And we'll see what this looks like just in a bit when we print this out. Okay, so that should be all of the changes that we need to make. So if I run this, let me make this a little larger here. Then if I did this correctly, now we should have the 5 most popular languages for each developer type. So here at the bottom, we can see marketing and sales professional, that most of them knew HTML, CSS. That sounds correct. But let's scroll up and look at some of these. And again, you can filter out NA up here in our loop if you want to. But we can see that desktop use JavaScript, HTML, CSS. Front-end developers mostly use JavaScript, almost 88%. That makes sense. JavaScript, HTML, CSS, SQL are the top 3. That makes sense. So designers are mostly HTML, back-end developers, JavaScript, full-stack developers. Academic researchers are mostly Python. So I believe that makes sense as well, because Python's becoming very popular in the data science field. And yeah, we can see a lot of them here. Data scientists specifically, or machine learning specialists, 80% Python. Database administrators, mostly SQL. That makes sense as well. Now let's actually go down to the embedded systems, since that was the specific question that the person asked on Reddit. So if I keep scrolling down here, system administrator, we can see that Bash made that list. That makes sense. Scientist, 70% Python. I think I missed the embedded applications. Yes, here it is right here. Okay, so we can see that 60% of people who said that they worked in embedded applications knew JavaScript. 57% said HTML, CSS. Now C++ made this list, and it didn't make many other lists. And that makes sense because C++ is a very popular language in embedded applications. And then we also have SQL and Python here, setting at roughly 51%. Okay, so the calculation that we did here, broken down by developer type, is a bit more advanced than what we started out with, but with the data that's available to us, we can make just about any analysis that we'd like. And this is great practice for anyone who's getting into data science, because this is a good example of downloading some real-world data and parsing out exactly the information that you'd want. It's also going to make it fun, since this is a survey about the developer field. It's kind of fun to just poke around in the numbers and see what we can find. So for example, we can parse out the median salaries for these developer types, what programming languages have the highest job satisfaction, what the most preferred development environment is for the different development types and languages, all kinds of stuff like that, to keep it interesting while learning how to do this stuff at the same time. And like I said before, this would probably be a bit easier if we were using a library like Pandas, but I didn't want to overwhelm anyone with that library who isn't familiar with it. So once I release the Pandas series, then I'll re-release an updated video doing the same thing that we did here, but I'll use Pandas to parse out this information instead. Now, before we finish up here, I'd like to mention the sponsor of this video, and that is Brilliant.org. So we've been talking a lot about data science in this video and how to analyze this data, but to learn more about data science, I would definitely recommend Brilliant.org. So Brilliant is a problem-solving website that helps you understand underlying concepts by actively working through guided lessons. And they've recently added some brand new interactive content that makes solving puzzles and challenges even more fun and hands-on. And if you'd like to learn more about data science and programming with Python, then I would recommend checking out their new probability course that covers everything from the basics to real-world applications and also fun things like casino games. They even use Python in their statistics courses and will quiz you on how to correctly analyze the data within the language. So their guided lessons will challenge you, but you also have the ability to get hints or even solutions if you need them. It's really tailored towards understanding the material. They even have a code environment built into their website so that you can run code directly in the browser. And that is a great complement to watching my tutorials because you can apply what you've learned in their active problem-solving environment, and that helps to solidify that knowledge. So to support my channel and learn more about Brilliant, you can go to brilliant.org/CMS to sign up for free. And also the first 200 people that go to that link will get 20% off the annual premium subscription. And you can find that link in the description section below. And again, that is brilliant.org/CMS. Okay, so I think that is going to do it for this video. I hope you found a video like this helpful where we go over a real-world example of some data analysis using Python. And like I said, this is great practice for anyone looking to get into the field. And it's also pretty fun just playing with the numbers and seeing what we get from that data. But if anyone has any questions about what we covered in this video, then feel free to ask in the comment section below, and I'll do my best to answer those. And if you enjoy these tutorials and would like to support them, then there are several ways you can do that. The easiest way is to simply like the video and give it a thumbs up. And also, it's a huge help to share these videos with anyone who you think would find them useful. And if you have the means, you can contribute through Patreon, and there's a link to that page in the description section below. Be sure to subscribe for future videos, and thank you all for watching.